All right, I want us to learn how to draw a Lewis structure. Um, we're focusing on covalent compounds now, and Lewis structures show us how the atoms in a covalent compound are connected. And then once we have a Lewis structure for the molecule, we can then make a prediction about its polarity, what its shape is, and that gives us an idea of how it's going to behave, what it is will be attracted to, what it dissolves in. So make sure that you have your instructions for Lewis structures beside you so that you can reference those steps. Those are the steps that I'll be going through. Okay. So we're going to start with a simple compound, like let's say we start with hydrochloric acid. It's a covalent compound because you have two nonmetals, and we want to show how these are connected, how the electrons are being shared in the compound. So if you look at your list, step 1 says identify the type and number of atoms in the compound. So in this compound, you have hydrogen, and you have one of them, and you have chlorine, and you have one of those. And you're going to need the valence electrons for the second step. So the number of valence electrons for hydrogen is 1, and the number of valence electrons for chlorine is 7. You're going to find the sum of those valence electrons, because those are the electrons that are available for bonding. So those are the electrons that we have to use to show how the molecule is connected. So the next step says we're going to create a skeleton. And if carbon is present, we start with it. If carbon isn't present, we start with the least electronegative element, which is hydrogen. But then the rule says you never begin with hydrogen. So we're going to start with chlorine. And what that means is we'll draw that symbol first, and we'll attach everything to it. So here's the chlorine, and we need to attach one hydrogen to that chlorine. Going to attach it with a line. And in your instructions for drawing Lewis structures, it says that when you connect the atoms with a line, this line actually represents a pair of electrons. Okay? But when they're being shared between two atoms, the pair turns into a line. Now, the next step says that we have to add electrons to any atom that has to have an octet. And between these two, chlorine is the one that has an octet. Hydrogen never has an octet, which means 8 valence electrons around it. This hydrogen only has that one electron. It can share a maximum of 2. So once you attach hydrogen, you're done with it. So the number of valence electrons is determined by this right here. Now you've already used 2 out of that 8 to connect them. So you're going to add the rest of the electrons out of this 8 to the one that needs the octet, to the atom that needs the octet, and that's going to be chlorine. So you already have 2 here, and chlorine is sharing that pair with hydrogen. 4, 6, 8. So that is the Lewis structure for hydrochloric acid. You double check to make sure you have an octet around any atom that needs an octet, and that's chlorine. You have 2, you get to count this pair, 2, 4, 6, 8. So you've used all 8, and you have an octet around the atom that needs an octet. Now, the next thing I want to talk about is polarity. If you look at this molecule, you can see that there is an atom that is not sharing the electrons fairly or equally. There is an atom that's a bully. There were 8 electrons that could be used to bond these two together. But out of these two atoms, one of the atoms is keeping many of the electrons to itself and not sharing the other electrons with the other atom, and it's chlorine. You can look at it and see there are pairs around chlorine that are not being shared with the hydrogen. Since electrons have a negative charge, this area of the molecule is going to be highly negatively populated. It's going to have a very dense negative charge in this area. So we're going to label this negative. This area will be less negative. This is more negative and this is less negative because these little dots represent electrons which have a negative charge. So instead of saying more negative and less negative, we label the area that is the bully, the negative end, and the other end, the positive end. So now we have a molecule where the electrons are not being shared equally. So it is a polar molecule. And to show that it's polar, we're going to draw something called a dipole, which is just a line with an arrow, and the arrow points in the direction of the bully, or the more electronegative element. So if we draw the dipole, the arrow is going to be in this direction towards the chlorine, and then we'll put a little positive tail here to represent the positive area. The last thing I want to talk about is the shape of this molecule. So we have a chlorine here attached to a hydrogen, and that shape is linear. And the angle for a line is 180 degrees.